Hello everyone. Today we want to talk about YouTube system design. This is similar to some other system design problems like Netflix system design. They have lots of common functionalities, non-functional requirements, and techniques. Let's get started. This is designing YouTube. What is the daily active users? Uh, 2 billion. I think 2 billion is it's not realistic, honestly. We should consider less than a billion, maybe 500,000 or so. But again, it's the scale of YouTube. The scale is like a big volume. But 2 billion, I think, is a little overestimation. Videos watched per day, 5 billion. Creators, the people who create the YouTube videos, 50 million. But the fact is that internet traffic, like 37% of internet traffic of all mobile usage goes to YouTube. So that is the volume of YouTube usage over the entire internet. So you can then guess the scale. And languages, YouTube supports 80 different languages. Okay. Then we know that what scale we are going to deal with, and we definitely should scale. We should design with the scale in mind. Questions: what are the most important features? Upload video, watch video. What devices? Mobile, web, smart TV. Um, daily active user. Daily active user 500 million. Um, so these numbers are not very accurate, but you get the idea of the scale. The most important use cases, as I said, it's going to be upload video and then watch or stream video. Average time spent on product, 30 minutes per user. International users, are they supported? Yes. All video format and resolution are supported. We are going to support different video formats. And we should think about how to design the system to support that. Encryption required? Yes, encryption is required. Different video formats are supported. What is the video size? Like small to medium or large videos? Let's say maximum video size is 1 GB. Again, these are estimations. 1 GB is the maximum video size. Um, I think it should be a little more than that. Maybe 10 GB is more realistic number. Should we leverage cloud? Yes, we can. Like AWS, Azure, Google, we can leverage cloud. This is a good question to clarify with your stakeholder, like your interviewer, uh, to see if we need to use cloud or we should have our own data centers, which in most cases it doesn't make sense. Although for companies like Google, that does make sense. They have their own data stores, they in data centers and data stores, because with the what they do and like the scale of their products, like YouTube, such as YouTube, it makes sense to have their own infrastructures and resources. However, for some other companies, it might not be worth it, like Netflix. As far as I know, Netflix is using uh, um, AWS. Partly, they are using AWS. for this purpose. And OpenCI, and AWS functional requirements. We said it's going to be video upload, the most important, video streaming. Non-functional requirement, we should have fast upload, smooth streaming, adaptable video quality, the system should be highly available, like highly scalable and reliable. Like for streaming this adaptable video quality, that is important. That's why we want to store all different format and quality and resolution of the same video, so that we can support that adaptable video quality feature. It means that if the bandwidth is not good at some cases, like let's say mobile internet is not as good as I don't know, like home's Wi-Fi, then we can adjust the quality to lower resolution to provide the user like a smoother interaction with the streaming video. Estimations. Let's talk about the scale, a little about cost as well. It's very important to talk about costs, especially when you are interviewing for engineering manager roles. Managerial roles is always good to mention about cost, because at the end of the time, lots of design decisions is kind of bound to companies' resources, budgets, and acceptable cost. Without that, most of the design is going to be useless, right? It's not gonna be able to be implemented in that setup. So let's talk about cost. We said we have 5 million daily active user. If that is the number, if each user watch 5 videos, only 5 videos per day, it means every user is watching 25 million video per day. And then let's say if each video size is 0.3 gigabyte, and if we are using CDN, and CDN cost per gigabyte is $0.02, then this is going to be $150,000 per day for CDN. 150K per day. That's a huge number, right? CDNs are expensive. Then that's why we always prefer to go with cloud storages as like our second option, viable option. It's good to know that CDN cost per gigabyte is around $0.02, and basically they are charging based on gigabyte usage. If that's per gigabyte usage, then you just can multiply that number, that cost, into the size of video stream in gigabyte, how many user do we have, and then how many videos are watched, and what is the average size of a video. Then it can give us the size of streaming per day, and then calculate the cost, which is a big number for city, and that's why maybe we'd better to go with a cloud solution instead. However, as I said, like for Google, they do have their own data centers, and they do not rely on public CDNs. But smaller companies, maybe for them that makes sense to go with CDNs. Um, I have another system design video about CDN. We talk in detail about all these aspects, like when to go with public CDNs versus like design our own CDNs. And I discuss all the trade-offs in that video. So cost is going to be per calculated per size of video stream, per gigabyte that we calculated. This is cost. Um, and let's talk about the storage now. How much storage we need? Let's say 10% of daily active users upload one video per day. If that's a correct assumption, then 10% of 5 million, and then let's say average size of a video which is uploaded to cloud, to our system basically, is 300 megabyte. Then it's going to be 150 terabyte per day. We are uploading new videos. That's a huge number, 150 terabyte per day, right? That's a huge number. So you can imagine, like for 5 years, for 10 years, you should multiply 5 or 10 in 365 and then in 150 terabyte, and you can imagine that's a huge number. And then from there we definitely need to scale data storage, um, whether it's like CDN or our own data centers or cloud. That must be scalable, definitely. High level design. Okay. This is our clients, whether it is a mobile client or like a desktop client. We will have a set of API servers to do some functionalities like upload video, then like recommendation, search, update metadata, sign up. Users are sign up and then they upload video, and then they see recommendation on their feed, all that. And then also we have streaming. Streaming is going to be from CDN or from cloud, or like our own data centers. In any way, that is another like workflow. Um, we need to separate these two, understand these are separate, and then we'll discuss each in detail. For upload, we'll use API servers. For streaming, we have other design here. So here I have combined both in one diagram. You could have it in two different diagrams, but let's get started and talk about the design, the different flows: upload flow versus streaming flow. And then we'll talk about some more advanced features like search, recommendation. These are a little out of the scope of this, because this system is because we want to focus on upload and streaming. And then if you have more time, you can also talk about search service and recommendation service. So we have our user. They want to upload a user. They are creator. They want to upload um, a video to our system first. First of all, they need to reach out to a load balancer, and then load balancer will route the request to a URL server. This URL server basically first authenticate the user. I don't have authentication system here, but we should. URL server maybe even before reaching out to URL server, that load balancer will redirect a user to an authentication server, identity provider server, and once it has been authenticated, then now the user will have access to a URL server, and URL server is going to provide a secure URL to user to basically to upload their video to that particular secure path. Okay, and that can be first, that can be like a cloud storage, the original storage, some kind of scalable cloud storage. User use upload their videos, let's say over HTTP, to this original storage, and then from there we will have this is going to be like a batch process behind the scene. We will have a video processing pipelines. This is not just like one server. This is going to be a pipeline of servers, and each of those nodes in that pipeline can be multiple servers, multiple workers working on videos. We will talk more about that pipeline later. At the end, the pipeline will save the processed, polished video in different formats, in different resolutions, and different chunks in, let's say, CDN, if we are using CDN, or another cloud storage. And the last piece of that pipeline, it will be writing metadata into a metadata DB. And that needs to be like in a async manner. Metadata will be sent to a queue, and then a set of writer workers will work on upcoming data in the queue and write the metadata into a metadata database. That metadata DB should be consistent. We are storing important information that must be consistent. We might decide to go with like transactional databases to use to make sure about consistency of our data. Yeah, this part is actually the upload flow. And for streaming flow, uh, what is gonna happen is the top right portion of these diagrams. User will reach out to a load balancer, and as you know, this everything is distributed. User will reach out to the like load balance, and this is like a hierarchy of GO load balancer distributed to be close to the users, and then eventually the request will reach to the streaming server, which is close to user location geographically, and then this streaming servers basically um, will um, read. First of all, they will read. They have like request parameters. What is the who is is requesting to watch which like video, and from that streaming service will reach out to metadata DB to get all the details for that particular video. Those details can be like we will have maybe the video has been stored in multiple chunks with different resolution, like in different locations. All these metadata needs to be written in this metadata DB. Then we fetch those information, and a streaming service will reach out to CDN to proper locations that receive from metadata DB to basically um, uh, fetch those chunks of data, and then these data will be streamed to user. Basically, a streaming service will send back the location of the user on CDN, and then a user start streaming video from CDN and using some streaming protocol. That should be a streaming protocol. Then like some streaming protocol that has the capability of pushing data from server to client. Maybe behind the scene, it's using a protocol like the WebSocket because we are pushing data, but it needs to be kind of advanced streaming protocol which provides adaptive streaming experience. It means that data is being transferred in chunks of data and be buffer in client side, and then will be loaded on client side, so that this way at any time we are providing user-friendly experience and continuously streaming videos without interruption to user. Also, depending on a streaming service, depending on the bandwidth, user connection bandwidth, might switch to different format of the same video. And eventually, I want to talk for low latency and faster streaming. We also introduce in-memory cache, which we can cache metadata because it's that metadata rarely is being modified. Once a video is uploaded, it has all its metadata. It's not going to change very frequently, so we can cache it so that streaming service can have access to that cache much faster. And the other way to make streaming faster is that to deploy streaming servers near to end user to reduce the network latency. That's all for this diagram. Now let's talk about video processing pipeline that I didn't talk much about it. I just mentioned that this video processing pipeline is not just one server, it's a pipeline of different server which that they have different responsibility. Let's talk more about this video processing pipeline. What is the responsibility of this pipeline? Chunking a video to smaller pieces, transcoding videos. It means that for compatibility, converting video to different formats. Okay, it could be MP4, MOV, AVI, different formats of the same video and different resolution. And resolution for different bandwidth and devices for a smooth streaming experience. So for compatibility, to support more clients and provide faster streaming experience, smoother streaming experience, we are gonna transcode the video to different formats and also different resolutions, and then save it. Especially for mobile devices, it is important. Network condition can change. We need to ensure to switch video quality automatically for a smooth continuous play. Smooth continuous play. Number 3, filtering, thumbnailing, compressing to reduce size. Algorithms such as codecs. So filtering videos, some videos are not proper. Maybe we need to do some kind of content analysis to make sure that those videos are following their our rules. And then thumbnailing and compressing in order to save costs and storage costs. Basically, we need to maybe compress video chunks and then save it using algorithms like codecs. 1 hour video take up a few hundred gigabytes. That's a good thing to remember. 1 hour video equals to few hundred gigabytes. And this is the pipeline. Let's say this is the original file in original storage, and then it might be a video, audio, or metadata. If it is audio, we will have audio encoding, and then that's it. On the client side, after streaming, it will be assembled. We have a metadata, which is like consistent data. We thought that we want to save in relational database, and we have videos. For videos, we have more work to do. That would be a pipeline. Video is going to be splitted, then inspection for like filtering, for like improper content or else, and then transcode them. It means convert them to another format and resolutions. Then thumbnail, create thumbnail for those videos, and watermark. Watermark is for copyright. Creating a small flowing image on top of videos to kind of tag them with the owner of the video in order to respect copyright rules and all that. Then video streaming protocol is dynamic adaptive streaming over HTTP. So the underlying protocol is still HTTP, but this is a protocol on top of it, advanced protocol on top of it. Dynamic adaptive streaming over HTTP dash, which is dynamic adaptive streaming over HTTP. Streaming protocol, adaptive streaming. They call it adaptive streaming. Why is adaptive streaming? Because it changes to different format, to different resolution based on the resources, bandwidth to provide, and also it uses buffering on client side to create like a smooth play experience. The other protocols that different companies are using, like Apple is using a protocol called HLS, HTTP live streaming. HTTP live streaming. It's good that all of them are, over some protocols on top of HTTP. Microsoft Smooth Streaming is used by Microsoft. Windows are streamed from the nearest CDN server near to them with lower latency. This is important, right? To have CDNs distributed near to them, CDNs or wherever that we have finally decided to store our video chunks. Let's talk about a deep dive a little bit. Optimization and parallelization. Uploading videos as a whole is inefficient, so we split it by GOP on client side. HTTP does have that. The HTTP protocol that, already provides that capability to upload files by chunk. Place upload centers close to users. Both upload and download. Streaming servers needs to be close to end user. Setting up multiple upload centers across the globe. Build a loosely coupled system and enable high parallelism. This can be achieved by async design, like for pipeline, for example. For pipeline, this is the actual implementation, right? This design, basically. Original storage will send um, a front service will get the files, videos to a message queue, and then not the whole video, the identifier of that video. Then we'll have download servers that will download these videos, and then we will have encoder servers that these are bunch of workers, and based on the scale, we can scale them up or down. And then after this, again, upload servers that they upload the chunks of data, transcoded data, to CDNs and distributed them across the globe. And even after this upload server, we have that metadata writer that we had in the original design. So if you, as you see, we have decoupled all these components in pipeline with message queues that provides a loosely coupled system and enables parallelism, because we can add more servers as needed to each node along this pipeline. Safety optimization. For safety optimization, for example, what we suggested is pre-signed upload URLs. Pre-signed, they are secured URL. We said pre-signed upload URLs to make sure only authorized user can upload to S3 blob storage, right? Without that, upload URLs, nobody is going to be able to upload to our storage. So users can reach out to some API servers, like via an API called post/upload, for example, which is a post, and then this API server is going to return pre-signed URL, and then user use that pre-signed URL to upload to original storage. Copyright, to use DRM, digital right management. Apple, Google provide such tools for copywriting, I guess. AES encryption, encrypt a video and set authorization policy. Video watermarking, we talked about this, and image overplaying on top of the video. This is for copyright. Cost saving, that is important to mention, especially for these kind of systems that the bottleneck is the storage, right? Because that needs to be scaled indefinitely, and if we don't optimize it, the cost will be out of budget. We should keep them keep an eye on the cost. So one way is CDNs are expensive. Only we can, if we want really to use CDNs, we should only save most popular videos on CDNs, and others on cost-effective storage, such as cloud solution, for example, S3, Azure Blob Storage. Maybe most popular videos goes to CDN, or we can run some ML models to understand what videos are popular on what region of the world, and then make them available on CDNs to those users, rather than having all videos populated everywhere, which is super expensive and costly. Number two, we might not need to encode less popular videos to save processing effort. That makes sense, right? If some videos are rarely watched, why should we put effort and processing power to send them through all the pipeline processing, like encoding, encrypting, whatever, right? We can analyze the access pattern and then provide these processing powers only for popular videos. Some videos are only popular in certain areas. Example, in India, no need to distribute them to other areas. Again, this is very important. This one is really geographically, consideration is super important. We don't need to save Indian movies in, let's say, I don't know, Russian data centers. It doesn't make sense. Um, Big companies create their own CDNs, partnering with their ISPs, internet providers. Um, it is important to analyze historical viewing pattern before optimization to have better insight on content popularity, user access pattern, and video size and else. Again, this is important to analyze historic viewer pattern using some ML models maybe to optimize our future distributions more efficiently. We will have more insight on content popularity, access pattern, video size, and all that. Fault tolerance. We want to talk about fault tolerance. We need to handle errors gracefully. When we are talking about fault tolerance, one of the issues that topics that we can mention is the error handling. We should handle errors gracefully and recover from them fast. Recoverable errors, example, transcoding error, right? So we can, for recoverable errors, we can retry for a few times before sending an error indicating that it's recoverable. For unrecoverable error, it means for a permanent error such as malformed video upload. Then we cannot do much, right? We can just return an error to client and put them in dead letter queue. So for transient error, for recoverable error, retry. For other errors is, like sending error messages and put them in dead letter queue. Servers, cache, queue, worker resources are down. How should we go for it? When we are talking about failure handler, think of errors that might happen. This server might go down, that server might go down, queue might be overwhelmed, network latency is too high. How we want to handle? Think about edge cases, think about the not happy path, and then uh, suggest solutions for those scenarios. Servers can go down, cache, queue, worker resources are down. What should be done? We should have a live replica or provision a new one. Again, depending on what is the failover acceptable KPIs. That what is the maximum downtime, acceptable downtime, or how much data this system can tolerate to lose. All those KPIs are important to find out with failover acceptable failover mechanism. Should we go and availability, right? If we are supporting a 5.9 availability, it means that we should go with active replicas, at least for for most critical components are our system. Sometimes we might have we have more time, like for our failover, we can provision a new servers, and we don't need active replicas. It all depends on non-functional requirement. Make it clear with your stakeholder. Older version of clients cannot split videos, split on server side. Older version of clients cannot split video. Okay, it means that basically client's browser. Older version of client's browser cannot split video to send over HTTP. So then the solution is splitted on server side. And most of the time, it's good not to, rely on client for this kind of work and do server side, unless sometimes that we can leverage like cache on client side, which can definitely help the bandwidth and make user experience faster. But like for processing things, we prefer, or like for encryption, all that we prefer server side processing and encryption, because at the end of the day, client can be hacked much more easier, and it's not a secure way to go for. Scaling out, scaling API, talking about scalability is super important. If you don't have time to talk about any other non-functional requirement, at least you should talk about scalability, because that's the whole purpose of designing distributed web, distributed system design. Talk about it. Talk about how you want to scale different components, how you want to scale database, how you want to scale API servers. Okay, scaling API servers are easy because they are stateless. It's a matter of adding or removing servers. Scaling database, they are stateful. It's not as easy as API servers. Now, however, um, still it can be done using sharding and consistent hashing, and also replication for high availability. Live streaming, when videos live streaming, okay, we want to see if we have, we are asked, at least we should know about live streaming. I have one other system design video in which I'm talking about Zoom system design, which is a live streaming. This YouTube, Netflix, they are not live. They have live feature as well, but them when we are talking about YouTube or Netflix, most of the time we are talking about recorded videos, right? It's not live. The system design is a little different, and now we want to say how they are different. When videos are recorded and broadcast in real time, similar to non-live, okay? For live streaming videos are recorded and broadcasted in real time. That's the difference. In real time, almost the same time. Um, Obviously with some latency, but the whole video is not recorded, at some time in past, and they are now we are just streaming the recorded one. In live streaming, recording videos and broadcasting it is in real time. Then the differences. What are the differences? The differences is that live streaming has higher latency requirements, okay? Because that's sensitive. Like we don't want to lose, for example, an online class, different protocols are involved here. We talked about Dash, dynamic adaptive streaming protocol. But for those for live streaming, there are some other protocols involved. Need lower parallelism since data are already processed in a small chunk and real time. Um, Yeah, as in this system design, YouTube system, we are chunking data. But in those live streaming data are already being created and recorded in chunk of data, and then and in real time. So we might not need to chunk the data as such that we did for YouTube example. Different approach for error handling, as taking long time is not acceptable at all. That's again, everything is live. Error handling in live situation is much more latency sensitive, and it's not acceptable for error handling or recovery from errors um, to take long time. Video takedown, videos that violate copyright or pornography should be discovered during upload process or later by user flagging. That is another challenge because everything is live. That's why we don't have much time to process things before they are broadcasted, right? So handling these aspects in real time does have their own challenges. One is video takedown, right? When something is uploaded and we have time to process it, like YouTube or Netflix videos, we have batch processes that will take care of filtering and all that. We have time for it, right? And then if something is inappropriate or whatever, it's not following copyright rules, we take that down, like without impacting the audience, right? But here, because things are live, detecting these issues, copyright violation or pornography issues, on real time, to be discovered during upload process is a challenge, and it needs a different like design and consideration, or maybe later we decide to also do user flagging, not to let them to be part of to do live anymore, for example. We hear about like YouTube or doesn't allow some users to go live, for some violations and all that. That is what we are discussing here, user flagging. Uh, this is all that I have for YouTube system design. I hope you find it useful and you learned from it. Again, none of us are experts in all different areas. The idea is to learn more in depth about these areas. If you are an expert, and or you possibly worked at these projects at Google or Netflix, you might have like deeper insight of these um, deep aspect of um, the systems, and you might be more familiar with some other techniques that are being used in practice. But the idea of this videos are to provide as much as knowledge, common knowledge, as much as accurate knowledge, and share it with more folks. I'm open to feedbacks, new ideas, better designs, and all that. Just reach out to me and let me know what you think. And I'm always happy to hear and see your designs. Thank you all. Have a great rest of day or night. Take care, and until next time, bye bye.